Piecewise defined functions are functions that that have different definitions on different intervals. So let's look at some questions that we can ask about them. So here's an example of a piecewise defined function. First, we want to see how we read this information. So first, we know that the name of this function is f of x. Now, f of x has two definitions, but it depends on when we use each definition. So if x is between -5 and -2, that's when I use this definition of f of x, which includes an absolute value. However, if x is just bigger than 3, for any x's that are bigger than 3, I'm going to have to use a second definition of this function. So the function has like different personalities depending on which interval we're looking at. So what does it mean to evaluate f of 4? That means when x equals to 4, what's the value of the entire function? Well, how do I know where to actually substitute the 4? Well, let's look at the definitions. Is 4 between -5 and -2? Well, of course not. So then that means that I cannot possibly use this first definition because my 4 is not in this interval. Let's look at the second part. Is 4 bigger or equal to 3? It is. So because my function is defined for 4, and specifically 4 is bigger or equal to 3, I'm going to have to use the second definition to be able to find my f of 4. So then let's go ahead and actually find it. So I'm going to use the second definition, which means I'm going to use x squared. So everywhere I see an x, I'm going to plug in 4 instead. So that's going to be 4 squared plus 3. So that's going to give me 16 plus 3, which is 19. So f of 4 happens to be 19, which is the same thing as a point on the graph 4, 19. All right, so let's go ahead and look at the next part. It's asking us to evaluate f of -3. Again, we're going to do the analysis. We're going to look at the x's. Is -3 that I'm looking for? So the -3. Is -3 between -5 and -2? It is. So then I'm going to use this first definition of my function to evaluate f of -3. So that's going to be the absolute value. Be careful now. The problem has a negative in there already, right? Here's the negative. So there's a negative, and then my x is -3, and then -2. So that's going to give me 3 minus 2, which is the absolute value of -1, which is 1. So what we just found out was that f of -3 is 1. And let me box it here as well so that we're consistent. And this is equivalent to the point -3, 1 on the graph of our function. There you go, that 4, there you go. Let's move on to f of -5. So let's go ahead and see. -5, is it between -5 and -2? Well, we gotta be careful. Is -5 bigger than -5? Well, it's not, because -5 actually equals to -5. But do we have an x anywhere that equals to -5? We actually do not. So this over here, this definition does not work for -5 because we're missing the equal sign. And then this one, of course, -5 is not bigger than 3. So we don't have a definition for x equals to -5, which means that f of -5 is undefined. So same thing for f of 1. Let's be careful. Is 1 between -5 and -2? It's not. Is 1 bigger or equal to -3? It's not. That means there is no definition for x equals to 1, which means that this point is also undefined. This problem is giving us another function f of x. This one happens to have 3 pieces. So how do we read these 3 pieces? Well, if my x is below 3, I'm going to use this definition. If my x is between 3 and 10, I'm going to use this definition. And if my x is bigger than 10, we're going to use this definition here. So the problem is asking us which of the pieces I'm going to use to find the y-intercept. Now remember that the y-intercept, that's the place where x equals to 0. Right? Because remember, an intercept is the place where the graph touches or crosses an axis. So we are looking for the place, if we're looking for the y-intercept, That's the same thing as setting x equals 2 to 0. And I'm making a complete mess out of that where, so let me undo that a little bit and rewrite it a little bit neater. So a y-intercept is the place where x equals 2 to 0. So in general, to find the y-intercept, you set x equals 2 to 0. So then the question is, which one of the pieces that we have x equals to 0? Well, x is smaller than 3 will have a 0 in there, right? It's definitely not going to be in the second piece because 0 is not between 3 and 10. And it's definitely not going to be in the third piece because 0 is not bigger than 10. So it looks like x equals to 0 is going to be in this interval over here because 0 is definitely smaller than 3. So we're going to actually use the first piece to evaluate that. So to find out where what is the value of the function where x equals to 0, that's equivalent to writing what is the value of f when x equals to 0. And in this case, we said we're going to use this first piece to be able to evaluate that. So that's going to be 7 times 0 minus 5. So that's going to give us negative 5. So this actually gives us the answer for the y-intercept. The y-intercept is 0, negative 5. So it's just a little bit of extra information that we were able to get. Let's actually do one more example since we're still on the slide. Let's actually find what's the value of f of 11. Now what does that mean? That means look for where x equals to 11. So is 11 smaller than 3? No. Is 11 between 3 and 10? No. Is 11 bigger than 10? Yes. So we're going to use this definition to find out. But notice there's no x in here. There's no x in here for me to plug in my 11. This is a constant function over here. This is a definition, a constant definition of a function, meaning no matter what your x is, y is going to be 5. So the answer to f of 11 is actually 5. So this was just an extra example over here, just so because the example happened to be nice to give us a little constant function there. So that was just an extra example. The first part is where we found the y-intercept question. So part A is asking us to find the domain of the function. This is equivalent to asking for what x's the function is defined. Well, it looks like the function is only defined for the x's that are between negative 5 and negative 2, and then for the x's that are bigger than 3. If you have a hard time imagining this, always draw a number line, because that really does help to visualize this. So here's our number line, negative infinity to infinity. We've got some points of interest, negative 5, negative 2, and 3. So negative 5, negative 2, and a positive 3. So what the problem is saying that the problem has a definition for x's that are between negative 5 and negative 2. So let me highlight it with a different color. So this definition here belongs to what interval? Between negative 5 and negative 2. So between negative 5 and negative 2, that's the definition of my problem. But notice that negative 5 is not included, so there's actually an open circle at negative 5. Now what about let's do it in black. The definition of x minus 2 is defined for only those x's that are bigger than 3. So only for those x's that are bigger than 3. So the red and the black shows the places where the function is defined. So which x's were used in the construction of this function? Well, the only x's that were used were the ones between negative 5 and negative 2, and the ones above 3. Anything else has not been used to create this function. So let's go ahead and write that in interval notation. So that's going to be negative 5 with a parenthesis because it's not included, to negative 2 with a bracket because we do include negative 2, and then from 3 included all the way to infinity. To find any intercepts, in general, if we're looking for y-intercepts, we are going to set x equals to 0. So that means we're going to look back at our function and see, okay, where is x equals to 0? Well, do I have x equals to 0 in my function? Well, notice that there's no x equals to 0 that's used in this function. So I don't have any y-intercepts because there's no way for me to create x equals to 0. So in this case, the answer is no y-intercepts. To find the x-intercepts, we set y equal to 0. So what does that mean? So in my function, this is my y value, right? So we're going to set y equals to 0, and we're going to see for each case what happens. So when I set y equals to 0 for the first case, so 0 equals 2, and let's take the first rule, 2x minus 1, we're going to get x equals to 1/2. But then if we're looking at our actual problem, do we have x equals to 1/2 in our domain? Do we even have that number in our domain? We do not. So then this is not going to be an x-intercept. So then let's look at the second case. When y equals to x minus 2, so we set the y equal to 0, and we've got x minus 2. And in this case, we get x equals to 2. So again, we're going to look back to our domain. Is x equals to 2 even a possibility in our domain? It's not. Again, if you're looking over here, this is a missing piece over here. We don't have a function defined there. So in that case, because none of them work, we also do not have an x-intercept as well. So no x-intercepts as well. All right, so part A of this example is asking us to evaluate f of -2. This means what? When x is -2, what's the value of y? So let's find where is x equal to -2. Here's x equals to -2. So what is my function doing when x is -2? Well, my function value is 2. So then the answer is when x is -2, f of x is 2. This is the same thing as writing x is -2, y is 2, and it's also the same thing as writing the point -2, 2. All right. For the second part, it's asking us to evaluate f of 0. So let's go ahead and look at where x is 0. Well, here is x equals to 0. Well, I do have a function coming really, really close to 0, but notice that that's an open circle, right? The function actually does not exist right at that point over there. But does the function exist at any other place at 0? It actually does. It has a closed point right here. So when x equals to 0, the function value is actually 8 right here, because the function when x equals to 0 exists right here, not right here, because that's an open circle. So then the answer is when x equals to 0, the function does have a value, and it is 8. So this is the same thing as writing when x equals to 0, y equals to 8, or it's the same thing as the point 0, 8. The next question is asking us what is the domain of the function. The domain means what x values were used in the creation of the graph. Well, it looks like the function starts right here at -6. And then we're using all of these x values, including 0, right? Because even though I have an open circle here, 0 is still being used in the function to take care of this point over here on the graph. And then we still use all the zeros all the way to the 6, but not including 6 because that's an open circle. So then the domain will be, we're starting off at -6, and then we continue all the way to 6, but not including that 6. The range is all the y values that were created that were used in the creation of this graph. So let's look at what's the lowest y value used. It looks like the lowest y value was -4, and it is included because it's a closed circle. And then we keep going, keep going. This y value of 0 also have been used, but right here, right? Because this one is an open circle, but that doesn't matter because the graph does have a point right here. So we're still using the y value of 0, and we keep going. Over here, the last y value used at the peak is 2. But notice, what's going on between 2 and 4? Do you see any graph over here between 2 and 4? There is no graph between 2 and 4. So another way to imagine this is imagine the number y equals to 3. Is there any graph that pairs an x with y equals to 3? There isn't. So these y values in between 2 and 4 are actually not used in the creation of the graph. And then again, we pick up the creation of the graph at 4, not including 4, and then going up to 8. So then the range of this function, let's see, we started at -4 because that was the lowest value, and then we went all the way to 2, so all the way to here, right? And we included that 2 because there is a point on the graph there. And then again, we picked up at 4, but not including 4 because there's an open circle right here. And then we went all the way to 8, including 8.